Hey, welcome to The Art of Code. My name is Martijn, and what you see behind me here are 5 different examples of easing functions. And easing functions are used anywhere you have animation inside of software. It's very likely that you're looking at an easing function. So if you have anything to do with that, if you're a game developer or you're working on some fancy UI with moving parts and whatnot, then you should definitely know what these are. And even though many softwares have these things built into them and you can just use off-the-shelf components, I always think it's a very good idea to really know what it is that you're using, and so I thought I'd make a video about it. Alright, so to illustrate the concept of easing functions, I'm going to use this toy called Shader Toy. It's a website, shadertoy.com. You can go there and follow right along. That's the cool thing about this website. Now, this video is not about shader coding, so if you've seen some of my other videos, you know that most of my videos are specifically about shader coding. This video isn't, so you don't need to have specific shader coding knowledge. So yeah, this is just to be able to follow along and get your hands dirty, which is kind of important. If you want to learn things, then it's good to play with it and to make your own discoveries. That's very, very important. So yeah, if you want to know about shader coding, check out my other videos. Also, while you're at it, be sure to subscribe. I noticed I have a lot of viewers that are not subscribed yet, and it doesn't cost you anything, so please just click subscribe and then you will never miss any future videos. Alright, great, so let's get started. So this is a new shader. I just click new over there, and let's just clean this up a little bit. Let's make a black screen. So for that, I'm just going to go over here and set everything to black, and this is just to kind of set up the scene for this tweening or easing function thing that I'm going to build. And I'm going to make the UVs in the middle, so that's high resolution.xy and then divided by y. So that's just a black screen. Alright, so now to illustrate this, we're going to have to animate something. So for that, I'm just going to make a little dot that moves across the screen. So for that, I can say call plus equals, and then I'll take a smooth step of the length of the UV minus some size of the dot, and then I have to make a blurry edge to it. Let's see what that does. Something like that. That's fine. And now I could multiply that by a color as well. So I can make it red, for instance, by multiplying it by red. Okay. And now, because I'm going to have a few dots that I'm going to move around, I'm going to make a function for that specifically. So I'm just going to cut this out here, from here to here. I'm going to go over here. I'm going to say float dot with a capital D, because with a small d it collides with the built-in dot function for the dot product, which we don't want. So be sure to have that capitalized. And then we're just going to stick that in here. And we can just return that, and as an input we're going to give it the UV coordinate, so back to UV, and now over here I can just say dot, I can just say dot UV, right? That does the same thing. Now I want to be able to move that dot, so in order to move stuff I have to remap this UV coordinate, so I can just subtract something from here. If I subtract 0 from it, nothing's going to happen, but if I subtract something from this, then it moves the dot, okay, to the left and to the right. And so let's call this X and let's call this Y, and let's expose this as well. So I'm going to go over here, say float X and float Y. Alright, so now over here I can say like move the dot up, for instance, okay, or move it to the right. Okay, so now I'm going to have, and by the way, this 0 dot or dot 0, that's just to indicate that this is a floating point value. If I don't have this, I'm going to get an error because it expects an integer. So that's why some of these numbers have dots, other ones don't have dots, It's just really like what I should write is this 0.0, but I'm lazy, so I just do it like that. All right, so now let's move this dot. And actually, before I do that, let's make a start line and a finish line. Okay, so for that, I'll just say if duvx, I'm just going to write it out. It's not, this video isn't about this, so smaller than like some small value, then plus equals 1, let's say. So that gives me a line, and I can move that line to the left and to the right. So let's just go from plus 0.8 to minus 0.8. So I could just put an absolute around this, and then I have the other line for free, and then make it a little bit thinner. Well, not that thin. I don't know, something like that. Again, this video isn't about this. Check out my other videos if you want to know more about this kind of magic I'm doing here. So now we want to move this dot, right? So we're going to move this dot. Actually, no, there's one more thing. So right now, if I give it 0, it goes into 0. It goes in the middle of the. It goes in the middle of the screen. I want it to go at the start line, and so the start and the finish line are at plus and minus 0.8. And so I'm going to remap inside of the dot function. I'm just going to make a remap function to remap it to the right position, and I can do that like that. And so now my dot is at the start position because I'm at 0, and if I set it at 1, it's at the end position. Okay, and so now I can call this x, let's say, and I can play around with that. So for instance, what I could do is I could say float x equals I time, let's say. So I time is this number over here, down here. It's an input. So if you want to animate something, you use I time. And so now I don't see the dot anymore because it's way off the screen right now, but I can reset it over here. And you can see like now I have a dot that animates. Okay, now it goes too far. We don't want that, obviously. So I am going to make it that it can the maximum can only be 1. So I can do this, let's say. So this min function just gives the minimum of 1 and I time. So if I time is larger than 1, it will just return 1. So now when it moves, if this time value gets larger than 1, then it will just stop at 1. Okay, so that's it. All right, so now we are ready to do easing functions. And I know this was maybe a bit cumbersome up till now. I hope you're still here, but like from now on, because I think it's kind of important that you kind of build these things by yourself so that you get a better feeling for these things. All right, so well, we have an animated dot that moves around. That's all great. Just for a lot of things, this is not the most realistic movement, right? Like if you, let's say, had a rocket, well, a rocket doesn't start from 0 speed and instantly has the full speed, right? It accelerates. It starts at 0 and it accelerates. So what accelerates, like what kind of function can we come up with that keeps accelerating? So for that, I have another tool called Desmos. It's up here on the left, Desmos. It's another website, which is a graphing calculator, which is very handy if you want to do anything with functions at all. Then this is a great website to check out. So what we just did was the linear interpolation, right? On the interval of 0 to 1, it just starts at like it instantly has its maximum velocity and it instantly stops at the end. So that's called linear. So let's go back here and let's call this linear. So this is a linear interpolation. So now, if we wanted a rocket that starts at 0 and just accelerates, well, one very simple thing to do for that is just a parabola, right? And again, it's on the interval of 0 to 1. Okay, so parabola starts at 0 speed and it increases as you go along, right? So let's add that. So let's add a second dot here. So let me just copy this. That's not linear, so let's take it out. And then, well, actually, so here first, let me just move this dot up a little bit. the existing dot that we have. So 1, 2, 3, 4. Let's put it over there. And now we have the second one. And the second one, let's make it a different color. Let's make it green. Okay, so now we have a green dot there as well. And that is going to be this easing, right? So that is called an ease in. So if you're ever in Blender or 3ds Max or Unity or maybe in Photoshop Premiere, you will see the term ease in. So ease, not easy, ease in. So let's make an ease in. So that would be x times x, right? So now let's see how that goes. Okay, great. So that starts slow and it accelerates. That is really cool. So let's move that one up as well. You just go 0, 0.2, let's say. And well, let's do the opposite of that. How can we make the opposite of this? So one that starts fast and it slowly comes to a stop. Well, we can start again with a parabola, and then we turn it around by putting minus, and then we move it up by adding 1, and then we shift it over to the right by subtracting 1 from the x before we multiply it by itself. And again, that's on the interval of 0 to 1. Okay, so we can make this as well. So let's try to make this. And now inside of Shader Toy, I can't do this. I can't square things like this. So we have to just make a simple function that can square things. So let me just go over here and make that x2 float x, and that just returns x times x. Okay. So let's make an ease out. So go over here. And let's put that at 0. So the ease out, it was going to be a blue dot. And ease out was x minus 1, and that's squared, right? That's squared, and that 1 minus that. Okay, so 1 minus x minus 1 squared, which is an ease out. So let's see what an ease out looks like. So an ease out starts quick, and it slowly comes to a standstill in the end. All right, so well, the next thing would be, what can we do for an ease in and an ease out at the same time? Well, for that we can just interpolate between this one and this one. We can do a linear interpolation. We can start at the purple one and end at the black one, like this. Let me see here. How would I write it? Well, I can call this A, and I can call this B. And now I can say for the other one, I can just say, well, you want to start at A, and then if we use linear interpolation, we get 1 minus x plus b times x. Okay, so what that does is let me just turn this one off. It starts as the purple one and it ends as the black one. And yeah, if you wanna write that out, if you want to work out the algebra for that, then you would get x squared and then 3 minus 2x. That's the same thing, right? 0 to x to 1. And if you watch any of my other videos, then you know what this function is. So leave a comment below. Tell me what this function is called. So let's try to make that. So I have to go over here and make another one. And this one is called smooth because it starts and stops smoothly. And it is x times 3 minus 2 times x. And now I have to put that in a different location at minus 0.2, and let's make it a different color. Let's make it purple. Okay. So now we have a dot that starts slowly and ends slowly. So You could imagine if you working on a UI for a game and you want like the button to whatever, when you click on it, it moves up or something like that. Well, then using a smooth interpolation could be really good for that. If you, for the blue interpolation could be good for if you had something on an elastic band and you let it go, then it goes quickly and it slows down in the end or something like that. The green one would be good for a rocket, right? Okay, now let's make one more, just for shits and giggles. Let's make one that goes from A to B, but it overshoots B, so it goes too far and then it comes back. And for that we can leverage what we already did here. So let's see here. So let's look at these two parabola over here, this one and this one. Yeah, I suppose I could just use this here. Let's just, so what we want is the red function, but now it overshoots. It goes too far and it comes back. Okay, in the same way, like this one, it goes too far. We could do the overshoot on both sides. So you have it that something wants to move in that direction, but before it moves in this direction, and then it shoots over. Okay, and then in the end, like it overshoots and it comes back. Because what we can do, so these are parabola, right? Like the black one and the purple one. Let me just actually take out the the thing here so we can see the entire parabola. Because watch what happens if I make this parabola steeper. So let's see here. Let's put a number here. See, if I make this steeper, then at 1, it's actually, it doesn't go through 1 anymore, right? So over here, right now, purple goes through 1, and that's why my red one, my red final, my final curve here that I will put like that, ends at 1. But if I make this steeper, then at 1 the purple parabola is way above 1, so it pulls the red one with it. Okay, so and similarly, if I go on the other side, right? If I multiply this over here by 2, then it pulls the red line down. Now, so let's try to implement that. So we have two extra values, right? We have, let's call this N and let's call this K, and now I can make sliders for those. Okay, and now I have control over this, right? So I can play around with that. So let's go over here, and that's going to get a bit too complicated for this. So let's make a function for that. So let's call the function overshoot. So float overshoot takes as an input an x, and as an output is going to give me some interpolated value. So now let me copy this, Control C, Control V, and let's make the make it yellow and move it down. Okay, and call this overshoot. Okay, and now obviously I need to build that function, right? So so for that, let's oh, and the overshoot also takes an n value and a k value, right? So an n and a k. And so for that, let's just make the a and the b. Okay, so a is just x squared. So float a equals x times x. And then b, yeah, let me just put it like that. And then b equals 1 minus the x minus 1 squared, right? And because I can't do squared, I have to use the function like that. Oh yeah, and then we have this one times n, right? So this one's times n, right? It comes from over there. And this one is times k. So k times that. And then we return the linear interpolation of that. So linear interpolation would be a times 1 minus x plus b times x. All right, so let's see what that looks like. So first, let me see what it looks like on Desmos. So let's do 2 and 2 for both the n and the k value. So at 2 and 2, and if I turn off the other ones, I expect it to go. If I want to go in that direction, like it starts going this direction, and then it shoots over to the other direction, and then it overshoots, and it comes back. So let's see if that actually works. So over here, let me take this out, and let me call this overshoot of x. All right. And then, oh yeah, and then I need 2 and 2. All right, so let's see. Perfect. So that goes back, and now it overshoots, and it comes back on the other side. Now, one last thing, which is that over here, like now this isn't smooth anymore, right? So like when it starts, it has an instant velocity backwards, and when it ends, it kind of hits the end hard. It doesn't slow down towards the end. So how can we do that? Well, we just have to make sure that what we put into this function, because right now what we put into this function is x, right? This is, and x goes linearly, right? X was like this. It goes linearly like this. And so you could see that the green line kind of butts up against 1, right? It doesn't slowly go down to 1, and also it doesn't slowly go down to 0. So what I can do, like, is just to put a smooth value instead of the x. And the smooth value, we already had the smooth value, which was this smooth step here, right? So if I call this s, okay, and now inside of this formula, instead of x, I use s. Now watch what happens. Now it is smooth again, and now I do have to change my n and k value a little bit to make it more obvious. But now you see that I can pull it out, and it still kind of comes down smoothly to a stop at the end, and over there as well. So yeah, so let's make it 5 and 5, let's say. So let's go over here and call this 5, and that 5. Oh yeah, and then so over here, instead of putting x into it, I put s into it, and my s. Well, I can just go over here, float s. You don't have to call it s. I can just say over here, I could just say x equals x times 3 minus 2 times x. And that should do the same. So let's see. Okay, so that, I mean, it goes a bit far on both sides, so maybe 5 and 5 in this case is too much. Maybe we want to make it smaller. Let's just go back to 2 and 2. But I thought that 2 and 2 it didn't do much. Well, it does. Okay. So there you have it. Those are easing functions, and you can use those to drive different parameters in your game or in your UI or whatever have you. So right now I'm using those functions to drive just the X position, but you can do that same interpolation between two arbitrary points. You can use that interpolation to drive a color change, or to drive the rotation of something, or the scale, or anything you want. And so easing functions are, like I said, they're usually built into your software, but you can make them yourself, and you can get pretty fancy with them. So yeah, so this is a very basic tool that you should really know, and now you do, so that's great. So please, if you like this, click like, click subscribe, leave a comment, tell your friends about this, and I will see you next time.